Hey guys, I'm here to discuss about arithmetic series. So what is this arithmetic series? Arithmetic series is the sum of an arithmetic sequence. So what is an arithmetic sequence? Arithmetic sequence is sequence which each term is computed from the previous one by adding or subtracting a constant. This constant is also known as the common difference. So in arithmetic series, there is a formula used in finding the sum of the arithmetic sequence. This formula is S sub n is equals to n over 2 times a sub 1 plus a sub n. S sub n is the sum of the sequence, and the n here is the number of terms. A sub 1 this is the first term, and the a sub n is the last term or the nth term. For our first exercise in arithmetic series, we have a problem here. So what we are going to do here is we are going to find the sum of the first 10 terms whose first term is 1 and the 10th term is 10. So for our solution, so let a sub 1 is equals to 1, a sub 10 is equals to 10, and n is equals to 10. And we are going to use our arithmetic series formula, which is S sub n is equals to n divided by 2 times a sub 1 plus a sub n. So we are going to substitute the given numbers in our formula, which is going to be S sub 10 is equals to 10 divided by 2 times 1 plus 10. We are going to solve it. 1 plus 10 is equals to 11. 10 divided by 2 is equals to 5, and 5 times 11 is equals to 55. The sum of the first 10 terms is equals to 55. So for our second exercise, we have a problem here. The first term of an arithmetic sequence is 4, and the sum of the first 15 term is 375. Find the 15th term. So what is asked here is we're going to find the value of the 15th term. So for our solution for our second problem, let a sub 1 is equals to 4, n is equals to 15, and the sum of the first 15 terms is equals to 375. Again, we are going to need our arithmetic series formula, which is S sub n is equals to n over 2 times a sub 1 plus a sub n. In this case, we are going to find the value of the 15th term using the sum of the first 15 term and our a sub 1 and the n term. And we are going to substitute our given numbers in our formula. The sum of the 15th term, 375, is equals to 15 over 2 plus 4 plus a sub 15. What we are going to do here is we are going to isolate a sub 15. So we are going to multiply both sides by 2. So the 15 over 2 is the 2 is going to be cancelled. So it's going to be 2 times 375 is equals to 15 times 4 plus a sub 15. And again, we are going to divide both sides by 15 to cancel the 15. So it's going to be 750 divided by 15 is equals to 4 plus a sub 15. So to isolate a sub 15, we are going to transpose 4 to the left side. So 15 minus 4 is equals to 46. Therefore, a sub 15 is equals to 46.
So now we are going to discuss about geometric sequence. So first, what is geometric sequence? Geometric sequence is a sequence where each term after the first is obtained by multiplying the preceding term by a non-zero constant. What is this non-zero constant? this non-zero constant is called the common ratio. The next that I'm going to discuss about is geometric series. So what is geometric series? Geometric series is simply the sum of the geometric sequence. So just like in in arithmetic series is the sum of the arithmetic sequence, and geometric series is also the sum of the geometric sequence.
So I have here an example of a geometric sequence. So we are asked to find the sum of this geometric sequence. So in geometric series, we have a formula. This formula is S n is equals to a sub 1 times 1 minus common ratio raised to the n power all over 1 minus r. So in this case, first we have to find the common ratio. So common ratio is second term all over first term. So 10 divided by 5 is equals to 2. So common ratio is equals to 2. So we are going to find the sum of the first 1, 2, 3, 4, 5, 6 terms. So we're going to find the sum of the 6 terms. So we're going to put here S 6. This means the sum of the first 6 terms. So a sub 1, so we're going to substitute. So 5 times 1 minus our common ratio 2 raised to the 6th power over 1 minus 2. So okay, so here we are going to compute the numbers. So first we have to raise this 2 to the 6th power. So again, we are going to need our calculator to do this. So 2 raised to 6th power is equals to 64. So 5 minus 1 minus 2, which is this is 64, I mean, over 1 minus 2. So by the way, why are we doing this kind of formula, but instead of adding these numbers one by one? Well, simply because it is too long, and we have this formula to make it shorter, but it's up to you to if it's longer or shorter, because once that this sequence have higher numbers, you cannot simply add those numbers because it's too long and it's too high. You have to use your calculator, and this formula helps you to make the work easier. So we're going to proceed to our formula. So S sub 6, sum of the 6 terms. So we're going to subtract these two. So 5 times so 1 minus 64, this is negative 63, and 1 minus 2 is equals to negative 1. So S sub 6 is equals to 5 times negative 63 5 times 63 is equals to 350. And since this is negative, so our number is also going to be negative. So negative 350. So negative 315 over 21. So we are going to divide this. Negative 315 divided by negative 1 is going to be 315. So the sum of these 6 terms is going to be equals to 315. So how are we going to check this? So we can use our calculator to add those one by one. So 5 plus 10 plus 20 plus 40 plus 80 plus 160 350. So based on our calculator, our computed sum in our formula is correct. So again, here I have an example of a geometric sequence. So we are asked again to find the sum of this sequence using our geometric series formula. So let's start off by finding the common ratio. So 12 divided by 3 is equals to 4. So now our common ratio is now given. So we are going to proceed to our formula. N is equals to 1 times 1 minus r raised to the power. So we are asked to find the sum of the 1, 2, 3, 4, 5, 6 numbers. 6 numbers or terms, so we're going to put here S6 because the sum of the 6 numbers, 6 terms. So our first term is 3 times 1 minus our common ratio, which is 4 raised to the 6th power of the number of terms over 1 minus our common ratio. So let's start off by raising 4 to the 6th power. We're going to use our calculator. So 4 raised to the 6th power is equals to 4096. So that's high. we are expecting that kind of number here because our number ended at 3000. 1 minus 4096 4096 over 4. So let us subtract these numbers. So S 6 3 1 minus 4096 is equals to negative 4095, and 1 minus 3 is equals 1 minus 4 is equals to negative 3. I'm sorry. So let us subtract this 2. Let us multiply. 3000 times negative 4095 is equals to 12,200. Negative 12,200. Right here, negative 12,285. So we are left up here by the negative 3, so we are going to divide this again using our calculator. Why am I writing this down? Negative 12,285 divided by 3. 4,095. So negative divided by negative is equals to positive. So 4,095. The sum of the 6 terms that was given here is equals to 4,095. So how are we going to check this? So one by one we are going to add them to find the sum. So 3. So I'm sorry, the previous calculation is 4,195. That is what happened earlier, and I have misclicked a button somewhere in our calculator. So now it is done. 3 plus 12 plus 48 plus 192 plus 768 plus 3072 is equals to 4095. So just like in our computed sum using our formula, means that our answer is correct.